Hey everyone, Alex Shein here, astrophysicist and astronomy instructor. And what I have right here is a meteorite. It's an incredibly ancient, beautiful piece of cosmic history, about 4.5 billion years old. It's actually older than our planet, a contemporary of our sun, and most likely made its way here from the asteroid belts between Mars and Jupiter tens of thousands of years ago. And look at it, hardly any rust at all after all this time, thanks to its iron-nickel composition. This rock was once destined to be the core of a planet just like Earth. But something went wrong and it ended up drifting in space. We call these remnants of planetesimals. For context, humanity only figured out how to manufacture alloys like this relatively recently. So how often do these things actually hit Earth? Well, metallic ones like this, not very often, maybe a few times a year. Stony meteorites, on the other hand, enter our atmosphere almost every day, but they rarely make it to the ground intact. Most of them burn up in the atmosphere or break apart upon impact. That makes them much harder to find than iron ones. A metallic piece like this can sit in a dry desert for tens of thousands of years, whereas only a professional can tell a stony meteorite apart from a regular earthly rock. But how dangerous are they? Well, generally speaking, not very, but things aren't quite that simple. What happens when they come down near populated areas? I'm sure you heard about the two massive booms that woke up two states back on May 30th. Or was it two meteors, or maybe one meteor and one jet? Or dare I say, a UFO and a meteor? NASA, the military, and meteorologists can't seem to agree. All of this happened just a few days ago in Boston and South Carolina. As the days go by, more and more interesting details are coming to light, and I think it's time we piece this puzzle together. What is flying over our heads, rattling our windows like fireworks right in our own backyard? Especially when it's not even the 4th of July. Is it really just a meteor? Grab yourself a cup of coffee. Today, we're going to pinpoint exactly where to look for this new meteorite. And yes, one more thing. It's time to find out who's holding back the truth. Because spoiler alert, the military is definitely playing games here. But let's take it from the top.
Let's start with the Boston event, because that one is pretty straightforward. Here's a map of the East Coast, right along the US-Canada border. Up here is Montreal. That's the furthest north where witnesses reported hearing the boom. And down here, on the southern edge, we have New York City and Philadelphia, where residents also heard a loud rumble. If we map out this entire area, we get a massive circle. Just look at the sheer size of the path this thing took. Moving on, we have some dashcam footage from Rome, New York. Check this out. Daniel Wilcox, a volunteer firefighter who was heading out on a fishing trip with a friend, caught the fireball on his dashcam. You can clearly see the flash and the descent. It happened right here, which fits perfectly into our witness radius. Now, the epicenter is right here, Newburyport, Massachusetts. Why there, and not the center of the circle? Because this isn't an impact crater. The meteor broke up high in the atmosphere. All that reached the ground was a massive shockwave, and the closest seismic station that registered the event is right in Newburyport. Let me quickly explain the physics of a meteor's sonic boom. The meteor travels at hypersonic speeds, pushing a massive wall of compressed air in front of it. When it disintegrates, it releases a sudden boom, and that compressed air travels downward in a giant cone. Because of the entry angle and atmospheric conditions, this invisible acoustic hammer slammed into the surface right over the water near Newburyport. And over here is Boston, the heart of the meteor storm. Even though the acoustic epicenter was near Newburyport, Boston is the most densely populated city in the area, which is why most of the reports came from there. That's why it became known as the Boston meteor. People couldn't actually see it because of the heavy cloud cover, but they sure did hear it. Now, look at this. Authorities claim the meteor shattered into countless fragments that sank into about 100 feet of water in Cape Cod Bay. That's right here. With all these points plotted, we can map out the estimated radius of the shockwave. It looks like this. Since more than half of this circle lies over the Atlantic Ocean, it makes sense why we don't have even more reports despite the massive footprint. Also, look at how perfectly the witness accounts align with the boundaries of this circle.
If we trace the sound, the shockwave pattern, and where the fragments ended up, we can draw the trajectory. Here it is, this red line. Honestly, we got lucky that the debris landed in the bay and not on the nearby cities. Otherwise, while we'd have plenty of samples to study, some folks would have had a very bad day. Based on how it broke up, this was a typical stony meteorite, meaning recovering it from the bottom of the bay is going to be incredibly tough. You can't just sweep the ocean floor with a metal detector like you would for an iron one. So what else do we know about our cosmic visitor? Picture a boulder about waist high. It spent millions of years drifting through the vacuum of space, and on May 30th, it slammed into Earth's atmosphere at a staggering 20 miles per second. Now, even though that's nearly 100 times the speed of sound, in cosmic terms, it's pretty average. We've seen much faster. At an altitude of about 37 miles, the extreme pressure and friction became too much. It lit up, burning almost entirely to ash, leaving only tiny stone fragments to rain down into the bay. But think about this. If a rock just 3 feet wide could create a shockwave that rattled homes miles away, what would a 300-foot asteroid do? And those aren't as rare as you might think. Astronomers call them city killers. They won't cause a global mass extinction, but they have more than enough power to completely wipe a metropolis like New York off the map. Unfortunately, searching for these fragments is a lost cause. It's just too expensive and dangerous. If you've caught the meteorite hunting bug, you're much better off trying your luck in Campo del Cielo, Argentina, where enthusiasts find hundreds of iron meteorites every year. Now, let's talk about what happened in South Carolina 2 days earlier. Let's head south, where the air gets warm and you can smell the barbecue and boiled peanuts. On May 28th, tons of locals reported that walls shook, windows rattled, and the ground literally jumped. But unlike the Boston event, which spanned all the way from Canada to Connecticut, this one was felt only within a small dozen-mile radius, meaning the boom was significantly weaker. And guess what? I checked the USGS site. No earthquakes. I checked the GOES weather satellites and every available NOAA sensor looking for a flash. Absolutely nothing. All we have are eyewitness accounts. One resident said, and I quote, "I didn't see a flash, but there was a trail. A strange, unusual trail, like something passed by leaving a line." Another witness said that about 45 minutes after the boom, they looked up and noticed a streak in the sky pointing right toward where the sound had come from. A third person reported, "I thought I saw the clouds light up for a second, but I can't be sure." If it were a meteor, we would have seen some kind of flash, reflection, or persistent vapor trail, but there was nothing. In fact, Bill Cook, the head of NASA's Meteoroid Environment Office, flatly stated it was not a meteor. So that leaves us with two possibilities. First, it was a meteor, but a very small one that broke up extremely low to the ground under heavy cloud cover, dodging the satellite sensors, with the sound only traveling a short distance. Theoretically possible. But here's the catch. Witnesses described it as a textbook sonic boom. What else could do that? How about a fighter jet breaking the sound barrier? When a jet goes supersonic, it drags a Mach cone behind it, slamming the ground with a single sharp crack. That matches the witness descriptions perfectly. And seismographs pick this up not as a circular wave from an explosion, but as a highly directional linear wave. Right there in South Carolina, we have Shaw Air Force Base, home to F-16 fighter jets that routinely fly supersonic. I've got it marked right here on the map, incredibly close to where most of the reports came from. But the US Air Force claimed that at 5:24 p.m., right when the boom occurred, all their jets were already on the tarmac. They said all flights wrapped up by 5 p.m. But then again, they would say that, wouldn't they? Maybe it was a transit flight from another base, or even a civilian aircraft, though the days of the Concorde are long gone and commercial flights don't go supersonic. Or maybe the Air Force is just keeping secrets.
So here's what we have for South Carolina. No flash, no NASA confirmation, a few vague reports of a trail, a wave pattern resembling a sonic boom, military bases nearby, and a direct statement from the USGS pointing to a sonic boom from an aircraft. As someone who has spent most of his life looking at the sky, I have to be honest with you. I can't tell you this was a meteor. If it were, our satellites would have caught it. They might miss it in visible light through the clouds, but their infrared sensors pick up almost everything. A lack of data doesn't mean nothing happened, but it tells us a lot. At the same time, we can't just jump to conclusions about a supersonic jet either. A sonic boom from a heavy jet usually produces a double thump, but witnesses only reported one. Plus, it happened after 5 p.m., when routine supersonic training flights over land are generally restricted. So what actually happened? Here are the facts. While the Boston event was almost certainly a meteor, South Carolina was definitely not an earthquake and highly unlikely to be a meteor since satellites saw nothing. That leaves a man-made source, a military supersonic aircraft, or something moving at supersonic speeds high enough to create a shockwave without lighting up like a space rock. The only issue is that the military is keeping quiet. The Air Force says it wasn't them. That could mean anything from not wanting to admit a flight violation to the fact that we're dealing with something other than a standard F-16. Personally, I think someone was just flying incredibly fast over South Carolina on May 28th. The military. No bad intentions, no alien invasion, no falling meteor. Just a typical, or maybe not so typical, day at the office. But that tiny shadow of doubt, the reports of trails, the slight mismatch with flight schedules, is still bugging me. If you have your own theories, let me know in the comments. And if you actually witnessed either of these events, please share your story or drop a link to your footage. We deserve to know what's flying and booming right over our heads. And remember, space is far more fascinating than you think. Keep looking up, keep searching for answers, and most importantly, never stop asking questions. I'm Alex Shein. Thanks so much for hanging out with me today. I'll see you in the next video.